Hi everyone, I'm Pinaki from SketchX Lab, CVSSP, University of Surrey. In this talk, we present our paper Democratizing 2D Sketch to 3D Shape Retrieval through Pivoting. This is a joint work with my friends and colleagues Dr. Bhunia, Anishan Chai, Shubhadeep Kole, Tony and Song. First, a brief introduction to the problem. We are interested in retrieving 3D objects, particularly chairs, by drawing a 2D sketch. As you can guess, this matching needs to be fine-grained. In other words, you want exactly that chair. Solving this problem is important because we live in a 3D world. But we tend to draw 2D sketches despite its importance. Training large-scale algorithms that retrieve 3D chairs from 2D sketches is difficult. This difficulty mostly lies in that collecting sketch annotations for 3D chairs is difficult. A simple example would be, given a 3D chair, you can view or see it from multiple different directions. And each direction will give you the same chair, but in a different pose. So which pose should you sketch? Front, back, 3/4? The current approach is to draw them all. That typically the front, side and 3/4. This is where our contribution comes in. We piggyback on some cute techniques that were popular in NLP literature, that is pivoting. Intuitively, the idea of pivoting is that if you do not have a lot of paired data sets, which is 2D sketch and 3D chair, you find an alternative data set that is easier to collect and that has paired 2D sketch and 2D photos from random poses, and a second data set that has paired 2D photo along with its 3D chair. In our work, we use Chair V2 dataset for this pivoting. This dataset comprises of paired 2D photos and 2D sketches. This dataset collection is much simpler. You click random pictures of chairs using your phone instead of a 3D data capture rig. Once you have these photos, you ask your friends to draw a sketch for it. To get paired 2D photos and 3D chairs, we use a small set of 3D chairs and render multiple 2D projections using Blender. Hence, Chair V2 dataset with paired sketch and photo along with 2D projections of 3D chairs form our two datasets for pivoting. A key element to notice in this approach is the difference in the distribution of 2D photos in 2D chairs and those rendered 2D projections. We need something to ensure that these two kind of chairs photos match to align our 2D sketch with 3D shapes. The solution is quite simple, a KL divergence loss between these two kind of chair photos. Right, so now that we have the pieces of the puzzle, that is pivoting for fine-grained 2D sketch-based 3D shape retrieval, let's collect them into a unified solution. First, we use 2D Chair V2 dataset to have paired 2D sketch and 2D photos. Second, we use some softwares like Blender to render the 2D projections of 3D chairs. This process is free of cost and requires no additional human annotation. Third, we need to align the distribution between the two kind of chair photos, one from Chair V2 and the other is the 2D projections. The resulting solution is that pivoting that helps us to avoid the cumbersome and hard to collect 2D sketch for 3D chairs. There is one last missing puzzle piece, 3D awareness. The sketch we draw is 2D, but the chair is 3D. Fine-grained matching demands precision. And this is where comes our contribution, which is lifting. To have this precision, we lift 2D sketches to 3D. More specifically, we solve a blind perspective and points problem, which essentially looks at a 2D photo and tries to predict its pose, such as rotation and translation parameters, which are equivalent to R and T here. This concludes our proposed framework, which has two key elements. First, a pivoting to solve data scarcity problem and a lifting to solve the 3D awareness to make it work for fine-grained setups. We present a few results. On the right, you have fine-grained sketch-based shape retrieval numbers measured in accuracy top 1 and top 5. On the left, you have some retrieval results. And please see our paper for more results. Thank you for your time and hope you enjoyed this work.